Hi friends, we're going to do a quick lesson on compound statements. So what is a compound statement? A compound statement is when there are at least two arguments on the same number line. So let's identify that. Let's name that. A compound statement is at least two statements on one number line. And feel free to pause this video at any point if I seem to be moving too fast, but I want to keep the video at a good rate so that you can get through the whole video without taking up too much of your time. So for problems 1 through 6, write whether the compound statement is true or false. So in math is very definitive. Either something is true or it is false. There is literally no in between. So when I look at 6 plus 1 equals 7, 6 plus 1 does indeed equal 7. But we have this word here, and. So for all of this to be true, 6 plus 1 needs to equal 7 and 8 minus. So since 6 plus 1 does equal 7 and 8 minus 6 also equals 2, this entire statement is true. Let's look at number 2. Is 5 greater than 3? Yes. Or is 7 less than 1? So although 7 is not less than 1, that is indeed false. We have or here, which means if either of these are true, then the entire statement is true. And since we're on this, let's go ahead and name our inequality symbols. This symbol right here is called a less than. This symbol is called a greater than. Then, of course, we have less than or equal to and greater than or equal to. All right, boom. Those are inequality symbols. It's best to just go ahead and memorize these symbols because we will be using it all of high school, not just ninth grade, not just algebra. All of high school, we're going to be using these inequality symbols. So let's go on to number 3. Number 3 says 3 times 4 equals 12. That is correct. But we have this and here, which means this also needs to be true for all of it to be true. 1/2 of 7 is 3.5, not 4. So this half is false, this half is true, and we have the and there holding together this compound statement. So since one of them is false, that means this entire statement is false. If this had said or, the fact that we had one that was true, then the whole statement would be true. All right, let's do a couple more. 9 times 1 is 9. Is that less than 22? Yes. 21 divided by 3 is 7. Is that greater than 6? Yes. Both of these are true, which means the whole statement is true. And both of them had to be true because we had or. If that's enough of that, let's move into graphing these compound statements. So we have x equals -2 and x equals 8. Let's go ahead and make a number line. All right. So since we have x equals -2, that means -2 is included in the solution. So it's a closed point. And we have x equals 8, which is also a equals. So that's included, which is a closed point. We just made a compound statement. Now I'm going to skip 8 and 9 because this is pretty much review. These are not compound statements. These are just individual inequalities. So let's go on to number 10. We have k greater than 5 or k less than 2. So let's graph it. Boom. All right. K greater than 5. That's an open point on 5. And the shading will be to the right because it is greater than. Then we have or k less than 2. So that's an open point on 2. And less than, we shade to the left. And we just graphed our first compound statement. Let's write a note down here because shading is very important. It's important that you know which way to shade. If you have a less than or equal to, we're going to shade to the left. If we have a greater than or a greater than or equal to, we're going to shade to the right. Less than is an open point, does not include. Less than or equal to is a closed point. It is included in the solution. And same thing for greater than and greater than or equal to. Closed point for greater than or equal to, and open point for greater than. Let's do number 11 together. Okay. M less than or equal to -8. So that's going to be a closed point. Less than or equal to is a closed point. So I'll put a closed point on -8. We shade to the left because it is less than. And for m greater than or equal to -1, it is also a closed point. And I'm going to shade to the right because it is greater than. All right, friends. So that is compound inequalities. That's graphing them. Can't wait to see you on the next video.